G'day, I'm Nick Dingle. Welcome to Lesson 4 of Programming Fundamentals Part 2. Now, this is going to be another multi-video lesson, just purely because algorithms are such a complex topic. So, since I've already mentioned the name, let's jump into what the hell we're talking about. Today, we are talking about algorithms. Now, just like with every other diagram that we've learnt in the previous section of this topic, we plan absolutely everything about our application, including how the code behaves. Now, to give you a bit of a backstory here, a lot of people think that algorithms are stupid. Why wouldn't you just jump straight into Python, start writing code, and if things happen, then just fix your code as you go? Well, to me personally, I used to think that was dumb as well. Why would you ever use algorithms? And there was a situation where I was creating a program. Now, this program, you could create what's called a logic circuit. Now, if you've ever used Redstone in Minecraft, you will know exactly what I'm talking about. Those are logic circuits. And to test a logic circuit, you create what's called a truth table. So in my program, you could draw a logic circuit. You could hit a button. It would produce a truth table, and then it would show you the outputs of your circuit. Now, this is all well and good. I could actually generate the truth table, but I was having issues trying to produce, like if you had multiple inputs in your circuit, getting the right kind of truth table produced. And I think I was up to something like 100, 150 lines of code to produce this truth table, and it was getting out of hand. It was ridiculous. So I went, all right, stuff this. I'll sit down. I literally had a pile of napkins next to me and a pen. So I sat there and I started drawing up some algorithms to try and create this truth table as best I could. And after a while, I realized there's a pattern. There is a really simplistic pattern, and I could easily write a little algorithm to create that pattern. And on that napkin, I managed to write code, 13 lines of code, in fact, I think it was roughly, that did exactly what my 150 lines of code did, but better. And when I wrote that algorithm into my programming language, by God, it worked. And it worked flawlessly. And it was amazing to watch. So algorithms can be incredibly handy. Don't discard them. But they are by far the most complex thing. So an algorithm is you planning your code on paper. And there are two versions of algorithms we'll look at very, very soon. But the question firstly is, what the hell is this thing called an algorithm? Well, it's essentially you are planning the code or the logic of your application. And realistically, think of it akin to something like a cooking recipe in the real world. You've got steps 1, 2, 3, 4 in order to produce something like a lovely sponge cake. You've got bedtime routines, like personally, I go to the toilet, I then brush my teeth, I then take my inhaler, and then I go to bed. Plain and simple. Traffic lights, same sort of thing. They're all got their own steps and routines. And even the same thing with like your Pythagorean theorems. Those are all algorithms. And the things that make them algorithms is that they are step-by-step instructions that you can solve a problem that you can repeatedly do. So here is my lovely algorithm here, written in what's called pseudocode, and we'll get to that in just a second, for cooking a bit of toast. So what is step one? Well, step one is get the packet of bread, take a piece of bread out, you place it in the toaster, you push the handle down, you wait until it cooks, you add your condiments like your Vegemite and your butter, not in that order obviously, and then you eat it. Hooray! Okay? And I can do that again. I can make another piece of toast, and then another piece of toast, and another and another. It is repeatable, it's in order, and it solves an issue that I have. Okay? And before we go into the types of algorithms and the standards that we should follow in this course, I have got two problems for you to solve. And I'm not going to do them for you except for the first one after I pause the video. I would like you to write an algorithm, just to list the steps of phoning a friend. Okay, think about what are the steps I require to phone a friend. What is each step? What are the edge cases? What if they don't answer? What if I get a message bank? Think about those things as well. And then secondly, a bit of a challenge for you all. I want you to write an algorithm to play tic-tac-toe that will either always result in a win or a draw. And it's possible. Go and have a look at some websites. There is a way to do that. So I'm going to pause the video, and when we come back, I'm going to take you through the steps to phone a friend, in my opinion. Okay, hopefully you had a go and you're ready to step into an answer. So let's write the steps for phoning a friend. I'm just going to write the words begin and end just so I've got a little bit of a standard for my algorithm. And the first thing you're going to do is you're going to get your phone. Okay. The second thing you do is you're going to look up your friend in contacts. The next thing is you're going to select phone call, and then you're going to wait for them to pick up. Now there's a couple of options here. Okay. If they pick up, talk to them. Okay. If they don't, if you get a message bank, leave a message. Yes, that's what you should do. If they don't answer, hang up and try again later. Okay. Then the last thing we're going to do is we are going to make sure we hang up. Maybe I should get rid of the hang up there as well. Okay. I'm sort of doing this on the fly if you can't tell. Okay. And then you can put your phone away. Some people are allergic to that, I know. But there's my little steps. I've tried to cover some of the edge cases in terms of like if they do pick up, you got to chat to them. If you get a message bank, you should leave a message. If they don't, we're going to try again later. But in every case, we hang up and then we put our phone away. And you can repeat those steps again and again to perform the phone call with different friends and things like that. So there's me solving that problem of phoning a friend. Okay. Now, there are two different ways that you can draw or write an algorithm in the real world. One is text-based and is a little closer to actual programming languages. And the other one is graphical. And you've seen both in this slideshow already, but let's dive into the deep end. The first one over here is called pseudocode. And if you break that down, pseudo is a word that means false, and code is just that, it's code. So this means false code. What it effectively is we are writing code that doesn't really represent any real programming language out there. It represents the features of programming language, like starting a function, putting messages on the screen, getting input from the user, using if statements, loops, lists and arrays and all that kind of stuff. But as you can see, it's very generic. Begin, guess capital. Print, what's the capital of Australia? Get the capital. If the capital equals, I've spelt that wrong, whatever, equals Canberra, then print correct. Otherwise, print try again, end the function. So all those features are available in Python, as you can imagine. Print is just that, it's print. Get would be replaced with input. In fact, you could replace both these lines with input, but that's fine. If statements are there, we just don't have the then word. And again, we've got print and else and all that kind of other stuff. Now, the flowcharts are more for like you graphically orientated people or people who want to share their code a little bit easier or their algorithms a little bit easier, because these tend to have, literally as the name suggests, a flow to them. They have a bit of logic just in the way that they are physically drawn on the page. We begin, we print. What's the capital of Australia? We get the capital. With the capital, so this diamond represents a question, but we'll get there. If the capital equals Canberra is true, print they're correct. Follow that down and end. If they didn't get it correct, try again, then go down to end. So it's got this real sort of step by step, follow the lines around until we hit that end box. But these both do the exact same job, okay? Pseudocode and flowcharts do the exact same thing. You just need to know how to do both of them. You are expected to be able to read both, write both, troubleshoot both. We'll get there very soon. But let's have a look at the standards for writing these codes. So pseudocode again means false code. It's a text-based way of writing an algorithm. And here's some of the rules. Keywords must be written in full capitals. Begin, end, print, get, if, then, else, end if. All those should be printed in full capitals. And just like with Python, anytime we go inside a function or an if statement or a loop, we must indent our code. Some kind of indentation to represent our different what's called control structures. And I will go through control structures before the end of this video. So these are the standards. Make sure you are doing it, because if you're not writing proper pseudocode for the course. All right, what about the standards for flowcharts? Well, for flowcharts, realistically, you have got a bunch of different symbols that I'll introduce you to slowly as we go along. we have got this rounded rectangle called a terminator. Now, terminators, beside being an amazing movie, is the begin at the top and the end at the bottom. We should only see one begin and one end. Okay? We have got rectangles which represent processes, or in other words, lines of code in our program. Print and print in this example are all a process because they are basically like an action. Do this is what a process represents. If you've got a parallelogram, you've got that slanted rectangle, that means an input or an output. In this case, we're just using it for an input. So get capital just here. We're getting something from the user. The diamonds represent decisions or yes and no questions typically. In this case, we've got, is the capital equal to Canberra, true or false? You don't have to write the word is if you don't want to, because it's insinuated by the diamond shape. Okay? And last but not least, I know I've jumped around a lot here, is this one here, a subprogram. If you've got another flowchart or another bit of code you've already written, you put these double vertical lines on the sides to indicate it's a function written somewhere else. Okay? So you can see I'm not using that example. The other thing, a couple of little rules with this one. Besides using these shapes as much as possible, you must have a bit of a spine, a top to bottom flow for your flowchart. You can just sort of do left and right, but it's a little bit awkward. Typically you start at the top and it flows down and eventually gets to the bottom where the end is found. Okay, the other thing is that you must or you should have arrowheads on your lines to obviously indicate the direction of the flow, because there are times where you might have a decision that goes back up and rejoins the line, and the arrowhead is really important to know which direction that line is flowing in. Okay, so those are the standards for our pseudocode and the standards for our flowcharts. If you haven't already, make sure you write down an example and your different rules for each of those languages for our algorithms, because what I want to do now, we're going to spend a little bit of time looking at what's called control structures, and then I've got a little question at the end for you. But actually, before we get there, I would like you to revisit those algorithms at the start of the video. If you haven't already, I'd like you to try and rewrite the phone a friend algorithm to use pseudocode, making sure you're using begins, ends, if thens, and end ifs. So even I would have to redo mine, and I will in a little bit. And if you've had a go at the bonus scenario, I would like you to rewrite that one as a flowchart. Okay? If you haven't done the tic-tac-toe, but you'd like to try a flowchart, do the phone one as a flowchart as well. So you've got both examples going on. So guys, I'm going to pause, let you guys do that, and I'm going to come back with an answer to the phone a friend pseudocode. Okay, and we're back. So I've decided to go split screen for you guys so you can see each one of these ones side by side. This was the one I did earlier, obviously, and I just went really basic with begin and end and all that, and the ifs. I've gone a lot more pseudocode now. So I've got the begin, but then I've got a name for my function at the top, which is really important. I've said a get my phone. I've used get for the friend's number. I've said call the friend. If the friend answers, talk to the friend. Else, if you get a message bank, leave the message. Else, try again later. And then we end all the ifs, hang up, and put the phone away. So it's the exact same thing over here. Perhaps I didn't put the wait in, but whatever. Okay, I think it's pretty nice without it anyway. That would be what I'd do for a pseudocode sort of step through phoning a friend style function. All right, let's have a look at control structures. Now, a control structure is essentially the basic building blocks, and you've used them if you've learned Python from the very, very beginning. Essentially, it is just like an if statement, a loop, a set of instructions. These are control structures because what they do is they control the way your code flows or the behavior of your code. Obviously, if you've got an if statement like this, only one of these processes will get executed, okay? And so that controls how our code behaves. So control structure, that's where it comes from. Let's dive in and have a look at what these control structures look like and what they are for both pseudocode and for flowcharts. And the first one is called a sequence. And he is the simplest one possible. He is literally line by line steps of code that are executed in the exact order that they are written, and we execute them one after the other. So if you see process 1, process 2, process 3, all the way down to the bottom. There's no if statements, there's no loops, nothing. This is called a sequence of code. And same thing for flowcharts. If you just see processes one after the other, rectangles one after the other, that is a sequence as well. Now, one line of code or one process in a flowchart doesn't really constitute a sequence. It's just a line of code. When you've got a couple of them, it's really important to know, all right, I've got a couple of lines of code. This one will be executed first, then that one second, then that one third, and they will always happen. So that's our first type, a sequence. All right, but what if we want to chuck in an if statement? Well, we call this selection. Now, we've got a bit of types when it comes to selection. These are just if statements, all right? As much as I call them selection, binary selection, there's another one I'll show you in a second, they are just if statements, okay? If we look on the left, we've got a very basic if statement. We've got if a condition happens, then run a process. So this is a binary selection in pseudocode. Over here, here's the equivalent in a flowchart. We've got the condition, so we lose the if word. We've got a condition in a diamond, which indicates selection. If we follow the true path, then the process happens and we follow it down here. If the false path happens, we just go straight down without any process whatsoever. So these are the exact same for a binary selection. Now, another binary selection is we've got an if and an else. And so for this one, if the condition happens, then process 2 happens. Otherwise, it's process 1. And same thing over here. If the condition's true, process 2, otherwise process 1. Okay, so these again are equivalent. The reason this is called a binary selection is there's only 2 paths to follow, one or the other. So that means as soon as you introduce an else if, or even more complicated, a case selection, we get what's called a multi-way selection. So this is like if you're doing multiple ifs, one after the other, like I did in my phone a friend, I had if, I had an else if, and then I had an else. That is considered a multi-way selection because there's 3 paths in my code for that one. So in a multi-way selection, there's a number of paths possible, a number of possible choices or cases. So what we do, if you have a look here, case where the expression evaluates 2. So this may be a menu system. Press A to start a new game. Press B to continue. Press C to go to the options. Press D to play multiplayer, things like that. So what it says is basically, what did they select? Did they choose A? Well, then I run process A. Did they choose B? Then we'll run process B. Did they choose C? We'll run process C. Did they choose anything else? You're an idiot. Please select something that is actually on the list. Okay, so that's what this is. It's like a big, long if statement. Same thing for the flowchart. What did they select in the menu? Did they choose choice A? Was it choice B? Was it choice C? Otherwise, you're an idiot, choose again. And they all come back to join that main path at the bottom. So that's a multi-way selection. Pseudocode and flowchart. Again, they're equivalent, the exact same. Okay, stepping forward, let's do one really complicated one. A nested if. So with these ones here, you've essentially got multiple if statements that rely on each other. So if condition A happens, then run process 1 and jump down to the bottom. But the reason this is not a multi-way is because have a look at the conditions. We're going from condition A, so that might be, did they select the main menu? No. Okay, well, did they ask to start a new game with a new name or something like that? Okay, nope. We'll go to this one here. If that's not true, then we jump to the else. Every single if has got a different condition attached to it. And have a look at the flowchart. This is the same thing, left and right. If condition A is true, we only run process 1 and then we end. Otherwise, we're going to go check condition B. That's true. Otherwise, it's false. If condition C is true, otherwise it's false. Everything else will run process 4, and then we finish. Okay, so this is a nested if. It's a bit of a strange one. So, looping. We've got loops in Python, so we need loops in pseudocode and flowcharts. This is where flowcharts really shine, in my opinion, because you can physically see the loop in the actual diagram, but we'll get there. So we've got a while loop. While a condition is true, run a process, and then end it. and that just loops. Just like we do in Python, we have a while loop with a condition at the top, and then you've got your code inside that while loop. Flowcharts. As you can see, we've still got the diamond. We use the exact same shape, and we run the process. And while that's true, we just constantly go back up and we keep rerunning that exact same chunk of code. And as soon as the condition is false, we jump out and we continue on our merry way. So this is called a pre-test loop. And the reason it's called a pre-test loop is because the test or the condition sits at the top of the loop. We check it first, then run the body of the code. Okay, so this is the body here and here, and we check the condition before we run the code. So that's why it's pre the code, pre-test loop. So if we have a pre-test, that means we have a post-test. So it means that we run the code first, then we check the condition. It's flipped literally on its head. So repeat this process until a condition is true, and that will repeat. But you can see that we don't check the condition first, we check it after. And that's what makes it a post-test loop. Same thing for the flowchart. We've got the process and we have a diamond under the code. And if that is false, we go back up and we start again. So the test again is at the bottom of the algorithm. Okay, and when it becomes true, we jump out. So it's a little bit different, but yeah, as you can see, condition sits on the top. Otherwise, it's on the bottom. So pre-test if it's on the top, post-test if it's on the bottom. Okay, we're going to skip past this for now because I would like to finish up this video. It's gotten very, very long. What I'd like you to do is have a look at this code here, and I'd like you to identify the 3 things that exist. I would like you to identify the sequence, the selection and what type, and the repetition and what type. And I'm going to leave it at there, guys, and we're going to jump into some more algorithms in the next video. Thanks for watching. Catch you in the next one.